Cars are rapidly becoming software defined, connected, and increasingly powered by AI. But as the technology evolves, one question becomes just as important as the technology itself. Are people ready for it? Bosch's latest Tech Compass surveyed over 11,000 people across 7 countries to understand how society views AI, the skills people believe they will need, and what this means for the future of technology. From manufacturing and mobility to the future workforce, the findings have important implications for the automotive industry. To unpack these things, I am joined by Dr. Caleb Munigety, who is Head Enterprise AI for Bosch India, and Shankar Rao, Vice President, Chief Information Officer, and Chief Digital Officer for Bosch India. Let's dive into the conversation. So, Shankar, starting with you, I wanted to understand, we have seen electrification, we have seen digitization, we have spoken a lot about software, we have spoken a lot about sensorization. But do you think that a major disruptive layer now is going to be AI, especially from the AI, especially from the automotive context?
I think AI is definitely the most significant and the biggest for all the three disruptions that you just mentioned, right? You really look at electrification, to me, it's more about changing the economics of powertrain system, right? In terms of, say, if I take any, passenger car which runs on petrol, we are talking about 2,000 to 3,000 moving parts, whereas an electric vehicle, right, has only 20 to 30 moving parts, right? And now, if you talk about digitization, it's all about your cockpit and how the cockpit is becoming more and more intelligent, and how it's able to connect the car to the outside world. Whereas AI, to me, is changing the competition itself, right? It's changing, the way right from production, sales, after sales, quality, supply chain. It's pretty much, impacting, all aspects, of the entire value chain. And to me, it's not about, what a car, for example, can do on day one that I receive it or any consumer receives it, but what value it can generate to me over the entire, life period of the car, right? And for companies like us, like Bosch, it also means that, just not about, the component that we sell to our end customers, but it's also the digital services that comes along with it, right? So in terms of, the pure commercial value of it, to me, this is definitely, AI is definitely the most significant and the biggest of all the three changes, the disruptions that you talked about.
Interesting. Caleb, in the last decade, the term mechatronics, mechanical equipped electronics, has become the buzz of the buzz of the town, automotive town, right? Are we nearing a stage with what Shankar said, what the report says? Are we nearing a stage where future vehicles will literally and theoretically, practically become AI systems on wheels?
Yeah. So Shankar actually touched upon the commercial aspects of it, and then why is it a disruption? The way that I look at when we say that it's AI systems on wheels, definitely yes. But if you just go back and see how the whole manufacturing and automotive have changed over the past, right? Previously, car was basically looked upon as a kind of a product where it used to get designed even before it is shipped, right? So they design it. Once they design it, they feel that this is the final product that I'm going to deliver, right? But at the end of the day, it's no more just that one particular thing that is happening with the car. Once you ship it, the real engineering starts even after that. That's because now you are looking at a car as a system which learns over time, right? And when it learns over time, you might see something interesting that is happening. Then you might want to learn from it and then maybe ship it as the next feature that you want to use in the car. Correct or not? So if you actually look at that particular perspective, the AI as a system on the wheels is actually making a disruption in a way that people have to think now even after they ship the car, right? So as I see it, when you actually take this as a standard now, which is going to come up in the days to come, the decision layer is changing from before you ship the car to after you have shipped the car, right? So in that sense, the intelligence that is there on the car that is coming on a day-to-day basis is actually now being fed back to the people who have manufactured it. And that is the reason why I say that the intelligence on the cars as a system, which lives on a day-to-day basis, will be taken into account going forward.
Perfect, perfect. Shankar, to expand on what Caleb just said, right? As an automotive journalist, I understand that Bosch is one of the top tier ones across the globe, not just in India, right?
Yeah,
But
yeah.
as that top tier one, where do you see AI, coming in very hot? Is it inside the vehicle? Is it inside the factory? Or is it in the supply chain? Is there one, or would all three be impacted and affected equally by AI?
I think, AI is definitely, having an impact in all the three. But if I want to, rank stack them, right, I will probably pick as of now where things stands, especially from the context of Bosch. I would say the impact that AI is creating in the factory is the highest. Of course, but definitely helping us to build supply chain resilience. AI is helping us on the supply chain part of it, and AI inside the vehicle. Yes, there's definitely a visible, customer experience that AI is providing. But as things stand today, I would say, inside the factories where AI is clearly having a, clear financial and business impact. It would be on lesser downtime, better quality, and faster shipment of our products to the end customers. So I would say a lot, on of course on being highly energy efficient in our shop floors, right, in the entire factory. So to me, if I want to pick, uh, one out of the three in terms of where AI is creating the maximum impact, I would say as of now, the way things stand today is in the factory, followed by on the supply chain, both on the inbound and outbound logistics, and then inside the vehicle.
Interesting. Thank you for saying that, Shankar. To add on, I wanted to understand, because when I speak to the VC world, the venture capitalists around startups, and especially when the topic is manufacturing, they have now this sentence, and they always say manufacturing is the wildest animal to tame, the most difficult animal to tame. So, Caleb, Shankar just said that AI in supply chain and factories is going to be a big thing. At the moment, it is a big thing. Do you think India can leverage AI for manufacturing, and can the rest of the world too? And if yes, how?
Yeah. So when it comes to manufacturing, right, one subtle difference that I see between what happens in India in the manufacturing terms and in the other countries outside. The AI that has been developed, okay, even in the context of manufacturing, when you go to the Western countries, right, they have some standard systems that will generate data in a standardized way, right? And all the algorithms that have been built are basically assuming that these standards exist, and then those models get used so much there. Definitely, AI can be leveraged in the manufacturing sector in India, but it has a caveat to it, saying that we cannot just copy and paste whatever the foreign playbook is. The reason for that is, if you actually look at the manufacturing systems here in India, the kind of equipment that we have mixed kind of equipment. Some are very sophisticated, some are age-old, some are vintage systems, right? Also, the data gaps that are existing as on today, they are also huge. Many times we have missing data in the data sets that are coming, right or wrong. So if we actually look at these sort of gaps that are there, that are existing, I would say that they are not bad gaps. They are actually good gaps, because that is giving us an opportunity to think about AI in a very frugal way, right? What do I mean by that is to actually work with AI under the constraints actually requires more engineering, more creativity to make AI more useful in the context of India. So that way, as I see it, in the Indian context, yes, AI can be leveraged, okay, to bring in all the integration that is required amongst every component that exists. But the point is, we need to get to a point of saying that we are not um, directly using whatever that is there that is existing outside of India, because we have to understand our systems and then bring the AI that is more suitable to our conditions, rather than saying that one AI playbook will actually work for everyone.
I'll just add a sentence to what Caleb said. In India, is a lot of focus on what we call as efficient AI, right? That's where Caleb mentioned about the frugality. So there's going to be a lot of focus on how the token metering, how do we really consume AI, and how do we ensure that the efficiency is built in every aspect of AI. So we are a little different. So that's the point that Caleb was talking about.
Perfect. I mean, I think Bosch now uses AI in one of every two plants, right? If I'm correct. Specifically, if we speak about automotive manufacturing, what could be some very good use cases, of AI that we can highlight here for our audience to understand better, when we speak about AI specifically in manufacturing? Shankar, if you could answer that.
Yeah. I think 4 or 5 things come to my mind, Mukul. The top of mind, what comes is the quality function. If I visit any of our plants, there's a whole lot of computer vision based visual inspection that we have done, where AI is definitely playing a big role in reducing the overall defect cost, and hence the downstream warranty related costs, right? Warranty related claims and costs. Right? So quality is definitely one. And the second, is on the energy efficiency, right? How we are really leveraging AI, in terms of how we are consuming energy across the entire, production facilities what we have. And third, I would say is on the maintenance. Third is on the maintenance, where we are really seeing a lot of predictive and preventive maintenance, really helping us to keep the unplanned downtime to as minimal as possible. Because India, we have really good business, and hence many of our factories are running pretty much all 7 days a week, and we really can't afford any kind of unplanned downtime. So maintenance is the third area I see, where there's a significant impact that AI is driving, right? And fourth is also on the scheduling, the smart scheduling, where based on the dynamic demand that our customer has, where in the line you're just producing what is actually required and not what the machine is fully capable of, right? So the smart scheduling is fourth. And fifth, a bit of inventory optimization, because as you know, inventory is one of the largest cost elements in a manufacturing setup. So I also see the fifth element being in the inventory optimization, specifically in the indirect materials. So these are the 5 areas that I feel AI is really creating an impact. And the 1 in 2 plants that you mentioned about, right, in Bosch, I see various aspects of these 5 areas being deployed, being used. And it's not just pilot, it's essentially being deployed at scale across our plants in India.
Interesting. With what you've said, are we close, or should I say, how close are we to self-learning factories, especially in automotive manufacturing? Caleb, what would you say? How close are we?
Self-learning factories is an interesting concept because See, we feel that self-learning factories are really not a possibility. But when you look at closely, right, there are already pockets, okay, where the elements that are required to building self-learning factories already exist. For example, do we have AI models that can self-learn whenever the new data is coming in? Yes, it can, right? Do we have the manufacturing lines which can understand when the demand is changing and then accordingly act smartly? Yes, it exists. So what I see with self-learning factories, as I see it is, there are definitely various pockets, okay, that are already existing. One thing that is really missing as on today is that how do we bring all of these components to make sure that the goal of self-learning factories is getting realized. But an interesting problem to solve with self-learning factories is, let's say, for example, if you are certifying a particular part or a particular system today, okay, saying that this is how it has to be certified, and then we leave it there. But as the factories learn going forward, right, we should learn the art of certifying a system which has already been certified earlier, because the conditions under which we are now certifying is very different, because now the factories, by learning themselves, they are also throwing out something new for us to understand, which we might have thought in the earlier that this is not the standard, but then it might say that this might be a new standard that you have to roll out. So for me, yes, definitely, there are elements that are actually helpful for building self-learning factories, but the real engineering challenge that lies is at a level where how do we understand certifying these sort of self-learning factories that we are building.
Interesting. And my next question is also around the engineering challenge, but that's not engineering components or ECUs or electronics, but engineering the workforce for the future. Self-learning factories, AI, software, does that mean that the factories of tomorrow will require lesser workers? Or does that mean that the factories of tomorrow will require a different breed of people employed on the shop floor and everywhere else? Shankar, would you like to take this?
Yeah. I think let me think and then respond. I think it's probably both. When I look at it, uh, essentially what AI is enabling is looking at some of the jobs which are more routine, more repetitive in nature, right? Like your visual inspection, like your material handling. Those jobs will definitely I see a potential that they would be shrunk, but there's going to be a lot of new other jobs that will come up in the factories, right? It could be, a data steward, somebody who needs to audit the, output of the AI, somebody who would need to validate the, AI outcomes, the models that AI produces, and somebody who has to be skilled enough to, really look at running a virtual value stream, right? So there's going to be, a whole lot of new, jobs, new profiles, that come in. Having said that, from a more from an industry and India in specific, right? I would say the need of the hour is definitely, looking at, massive reskilling, because with reskilling is where, I would say uh, the workers from a compensation and from the capabilities what they provide will also be at a different scale. And to me, I'm more looking this not as a it's more of a workforce transformation, right? It's more of a workforce transformation rather than just an industry question. So we really need to look at it from that lens in terms of how do we transform the workforce at scale so that India as a country, we are ready for this new age of where AI does a whole lot of things which were earlier not envisaged, and AI is really acting as a augmenter to a lot of the existing workforce. So I would really look at it in terms of the workforce transformation.
Yeah, just to add what Shankar had talked about, right? That it's both. It's not a either or question. It's both this and that question. One thing that I wanted to add into the skills list that you talked about, Shankar, is See, the easier problem to solve is to get people who are very much into AI, which they themselves call as AI researchers or let's say the engineers. The other easy part is also to get the mechanical engineers. But when it comes to the industrial AI or automotive related stuff, right, you want to have a persona which is a mix and match of both. So we want people who are also good at automotive engineering, people who also understand at least at a level that it has to be understood what AI is, what data is. So we are not really looking at some specific roles like saying mechanical engineer or AI engineer. We want really bridge engineers who can bridge both of this and then start working together, right? So that's the kind of a skill that we actually are looking for, and it's not easy to get them.
And if you really look at the future roles, right, the role definition itself will change, Mukul, in terms of, how a production planner or a customer order planner, how he would do the role, the job description of these roles would definitely change, with a lot of, AI enablement and AI, way of working. So I would say, there's a lot of reimagination of the roles with AI embedded in the way they work.
Interesting. Now that we've spoken of engineering and you've spoken of AI and software, I think it is only if we touch upon electronics and semiconductors that would make this conversation more holistic. The amount of semiconductors going inside vehicles are increasing like anything, right? If I may say so, for every code to run, if code was blood, electronics are the veins it runs through. It runs through, right?
Okay.
And more codes we write, the more veins we would need. That's a given fact. But then, when we look at this increasing semiconductor content, is this a signal that the shift from mechanical engineering towards electronics-led intelligence has already happened, or has it just started? What would you do say, Caleb, if you would want to take this?
Yeah. See, the way that the semiconductor market is playing out, it's very interesting for the reason that at least in the past decade, when I look at car as a system, right, because of this software defined stuff coming into picture, because of the intelligence layers that we want to build, definitely to actually cater to that workload, we have to have the chips on it. Okay. So as I look at the numbers, it has almost tripled in the past decade. Okay, on the car, the number of chips that it has as on today. But when you actually look at the chips, what we are talking about in the context of automotive, what you see as consumer chips that are already there in the market, they are pretty different when compared to what we look as chips on the automotive car, right? The reason for that is you don't have a bigger playground in car where you can actually fit in chips of very large size. And you can also not play with the safety aspects when it comes to the chips, because the chip that you are embedding into the vehicle has to sustain, okay, maybe in a night in Himalayas, right, to a great heat in Rajasthan and across a span of 15 years, correct? So the kind of chips that we are talking about on the car are very specialized chips. One, because of the safety criticality that comes with the vehicles. The second is the size of the chips that we are wanting to embed into. The reason is you now have to think of AI in a very different way. You cannot really speak about large scale AI models, okay, that can run on cloud, but you are actually bringing it on small chips that are being embedded, and building an intelligence layer on those smaller chips is much more difficult. So the question related to the semiconductor part and the chips is not really whether we require it. Yes, we require it more because as the AI workloads become more, we require more chips, but we require more specialized chips that are being put in the context of the car, which has to sustain all of these factors that I have explained. So that is how I look at the increase in the semiconductor and the niche chips that we want to have getting embedded into the vehicles.
Interesting, very interesting. I mean, I'm really what really interests here is how would the future of tier ones look like? We already kind of know what the future of vehicles would be. On that note, one of the key trends that has happened in the last 5 years is tier ones have moved on from being mere component suppliers to becoming system integrators as well as system designers and manufacturers, right? But then going forward from here, Shankar, do you think that the future tier one suppliers will be judged more by software and AI capability than the traditional hardware capability?
I think hardware capability is required. I would put it as having deep hardware expertise and credibility is kind of a license to operate. You need that. That's you can't do it without that. I mean, that's what gives you an entry and also the license to stay in the market, right? But what really differentiates is your data and AI and the software capability. That's what consumers going forward will pay money, and the brands will also differentiate themselves from each other based on the software and the AI capability, right? So I would say it is, and as a matter of fact, very recently one of our marquee customers that sent me a huge list of audit questions, where a lot of those questions were related to how we in Bosch are really using AI and data for drawing intelligence, for driving efficiency, for driving productivity. So, even our customers are, looking at how the entire supplier ecosystem is really, looking at leveraging AI for driving efficiency and, having a better experience that, we during our interaction with them, right? So I would say, the future, would belong to the companies and including, us, where we have deep, hardware capabilities, but at the same time, we have enough and more competence in AI, and companies which think of AI and data as a core and not as some, side, activities or side, capabilities that they need to talk about. So AI should be, as part of the strategy, as part of what we represent, should be at its core. And those are the companies that, to me, would survive or would have a larger share of the market going forward.
Interesting. Shankar, I wanted to ask the next question to Caleb, but then now that you've brought in a point wherein you've told me that one of your customers called you and asked you how Bosch is using AI across. So, a lot of, a lot of people still in India, and when I say a lot of people, I mean from the automotive ecosystem itself, see AI as limited to autonomous driving. Is that too narrow a view, Shankar? AI
Yeah.
only, related to autonomous driving. That's it.
Yeah, no, I think it is too narrow a view, because AI is much bigger than that, much more than that, right? It's, a lot on, the intelligence cockpit, the human interaction we have, the preventive and predictive maintenance part of it. It's also about, really being aware of the context, the entire personalization, prediction, the cybersecurity aspect of it, right? It's much more than that, right? So to me, any companies which is looking at purely an autonomous driving, they are looking at a payback period which is much longer, rather than companies which are focusing on a lot of this intelligent automation that work together and which creates tremendous value to the consumer, is the one that has not only an immediate payback but also is really differentiating in the industry, right? So I would say companies which are really focusing on those multiples, I would even say thousands of intelligence components that working together that creates a value, whether it could, when I say create a value, it could be in terms of my personalization, really understanding what I do on a day-to-day basis, or the intelligent, the voice assistance, right? Or, the self-healing that really comes in, or, ensuring that I don't have any inconvenience of a car, breaking down, going there, right? So it's a lot of those things that really adds value rather than autonomous driving and not focusing purely on autonomous driving. I would totally, agree that focusing entirely on autonomous driving is too narrow a view.
Interesting. Caleb, to add to this, one of the biggest challenges today faced by automotive OEMs, tier ones, tier twos, also software teams, is the shrinking product cycles, product development cycles. There used to be a time wherein a car would take at least 3 to 4 to 5 years.
Yeah.
Right. Today, I don't want to mention the speed of China, but even if we look at India, that speed is coming down to 2.5 years. Right. That's what we are talking about. That's what we have started talking about. Can AI help reduce these development cycles, especially for automotive electronics and embedded systems across the value chain? Uh, you know, AI usage by an OEM or maybe somebody like VVDN or Bosch. Can AI do that?
Yeah. So a resounding yes to that. Okay. The reason for that is when you actually look at the speed at which the codes get produced, right, at these days, AI can produce it much faster than what a human can. Okay. Very good. And it is also reaping benefits in terms of saying that it is around 30 to 40% reduction in the development cycle. Okay, that's what it's being seen across the world. Okay, there's no question about that. But the fact remains, is it only that we are looking at AI for development purposes in the paradigm of code production? I would say no. The reason for that is there is much more thing that we can leverage with AI, because the hardest part of the engineering in the automotive or manufacturing is whenever you produce a part, right? That has to go through a kind of a verification and a validation process, right? Every part that you produce, it actually has to go through a verification and validation process, because that is where the real metal comes out, saying that whether this can stand the time of the test that is going to come in the days to come. So this code production part or code generation part is already being leveraged. But a big miss or a gap that I see here is how you can actually use AI to also maybe speed up the kind of verification and validation that you want to do. Because AI can also give you the data, okay, especially with respect to the edge cases, okay, where it is required when it comes to the training of AI algorithms, where you don't get most of this data from the field. Previously, it was like driving thousands of kilometers or doing simulations, right? And then saying that this part will stand the test or not. But now, more than code generation, right? I would like to see the people using AI in a kind of a judgment where they can tell AI, hey, these are the kind of scenarios that I also foresee that might come, but I don't have the required data to train my algorithm so that it can take care of the edge cases. So the way that AI can actually also speeden up this is you can just give it maybe 2 or 3 scenarios which are edge cases, but AI can actually bring in more varied scenarios. Okay, of course, which has to be realistic in a kind of a synthetic sense. So it can generate more and more data even to speed up your verification and validation, rather than just saying that you are using AI for your code generation, which I see is a trivial part. But using your judgment and then using AI to generate synthetic data which doesn't exist or doesn't come from the roadways, okay, is much more reaping a benefit from AI than saying that we are just using AI for development purposes.
I think the point what you mentioned is also what I'm also seeing, Caleb, is a lot on the where AI can really make a difference is on your validation, correct? Right? Testing and validation. So where instead of actually doing the physical testing of driving 100,000 kilometers in on the road and under various different conditions. The same thing can be simulated. AI can actually do the job of simulating and give the results. So, I mean, apart from the coding, just want to add to what Caleb was saying. It's also on the testing and validation. I mean, here testing, validation, verification. We also call verification. So that is where I see there's a lot of impact that AI is creating in the automotive side.
Perfect. Now you gentlemen operate across sensors, ECUs, software, semiconductors, and manufacturing, right? And there used to be a time wherein when I used to start when I first covered IoT, Internet of Things, and then came in IIoT and everything else. It was good to have all your factories connected onto one platform. Maybe one in Haryana, one in Punjab, one in US, one in somewhere else. But when it comes to different verticals, the ones that I mentioned, ECUs, semiconductors, manufacturing, do you think connecting all those verticals under one intelligent stack is now possible? And how much of a possibility is that? Can we do that completely now? Caleb, would you like to take that?
Yeah. So it's an interesting thing that you have brought in. Whatever you spoke as different things, right? The ECUs, for example, and the silicon that we talked about, right? See, we have to understand that prior to AI era, right? These were all looked upon as different systems, doing different things and producing different artifacts, right? Correct or not? So manufacturing actually produced processes, right? Where in which the ECUs that you talked about actually was looking at standard certifications and so on and so forth. So every part that you talked about was doing a particular thing, and it also had specific audiences and the language that it used, right? So in one sense, these artifacts that you were seeing were actually looked upon as heterogeneous artifacts. What happened with the advent of AI was, it made sure that all of these different active artifacts can have a common language, and that common language is data, right? The moment it has started homogenizing in the form of the language of data, okay, it's no more that we are going to lose anything when we are translating from one system to the other system. It's more of a plumbing job, that how do you tie the loops between these artifacts so that we can actually extract the intelligence in a common integrated way. And that is where I think the most of the focus is on today. How do you actually tie the loops between these things, get a common understanding, right, with a similar language? And that is how I would see going forward, the integration would actually add up to the intelligence that we can reap in an integrated manner.
Interesting. An extension of the question, Caleb, do you think AI would widen the gap between technologically advanced suppliers and smaller traditional component manufacturers?
This is a kind of a question that can have two responses. If we say that it has to widen, it is all dependent on us, whether we really want to make it wider. Okay. There is another way of looking at it. See, right now, there are two parts to the gap that we are talking about. Okay. One gap is really the access to the frontier models that are existing as on today. Okay. The AI models themselves. Now, but when you see the problem that is now appearing to be a cost when it comes to the access of the frontier models, it's an easier problem to solve, because going forward, even if you see the companies, right, that are actually producing these OEA models and then giving it out, they are definitely wanting to reduce the cost so that it is even accessible to the common man, right? So that way, of course, that's a problem to be solved, but then it is being solved already at a fundamental level where people are giving access to these models at I wouldn't say lower cost, but then at a cost that one can bear. But there is a problem beyond that, which can actually widen the gap. See, for example, the companies like Bosch, like ours, okay, if you see, they have a legacy of 100 years through which they have learned the art of engineering at depth when it comes to manufacturing, not automotive. We agree with that. The other companies, okay, which are newbies or maybe somewhere in the middle of the spectrum, they also have the access to the AI models, but the problem is that they don't have sufficient engineering depth. So for me, when I look at AI, intelligence is one part of it, but then the engineering that you do around it actually makes AI more useful, more safer to use in the context of manufacturing and automotive when we look at from that lens. So for me, gap might exist because these companies don't have that engineering depth, which actually makes AI more useful rather than the intelligence that exists in the AI in the first place. So for me, yeah. So for me, when I see this as a gap, it's not now on the AI to solve this problem, but it is on tier ones like us, okay, and the tier ones across the world to make sure that how they are able to even get this engineering knowledge go into the smaller players so that they can also make good benefits out of the AI by properly engineering around it. So that's how I see the gaps can get reduced. And in that context, we should also have a kind of a forum where people talk about these gaps that are existing. And we should also have a kind of a development plan that we can take it to the smaller players so that they understand and then get benefited out of it. That's how I see gap, whether widening or not widening, but then we have a part to play as the humans in the loop to make sure that AI is being used in a democratized way to get the maximum benefits out of it.
Perfect, perfect. Thank you, Caleb. Shankar, if we move on from the automotive ecosystem and speak about consumers for a little bit of time, right? Today they see AI and autonomy for sure, but where do you think they would genuinely get to experience AI in the vehicles, in the automotive segment beyond autonomy?
Beyond automation. Automation.
Autonomy.
Okay. Beyond autonomy. I think first is definitely the voice assistant, right? Inside the vehicle, the voice assistance, which is context aware, which is personal, and then second is on the personalization or the hyper personalization where it exactly knows what my routines are. It predicts and enables me. For example, it knows what day of the week and what time of the day that this is my routine. This is the routine that I follow, and it enables me to make sure that the car is driving to based on my routine of for that day, right? And also a lot on the personal preferences, in terms of the driver profile that we talked about, based on my profile, what's the temperature in the car that I really like, what's the song or podcast that I want to listen based on the day, right? So it's on that. And more the other one where I really see a lot of value is also on the safety aspect of it, right? It's more on making sure that the vehicle health is there's a self healing that happens, and unplanned breakdown does not happen, and it does not cause me any kind of inconvenience, right? So this the third aspect, one is the voice assistant, second is on the the personalization that takes into account my preferences, right? And the third is on the vehicle safety aspect of it. I think these three, I would say, of course, there are a lot more, in terms of how AI can really inside the vehicle drive, make it highly energy efficient, right? Whether it's a EV vehicle, how do I, the thermal part of it, the thermal management part of it, or the battery optimization. So how AI can really drive, the overall energy, utilization of the vehicle, right? So these four, I would say, is to me where I see AI in the vehicle playing a major role.
Interesting. Does that mean that AI will also become critical for battery management systems? You have already said energy optimization, but
Yes.
how critical do you think, Caleb, would you like to take this? I mean, how critical will AI become in battery management systems and, as Shankar said, also in energy optimization?
Yeah, battery management is a very interesting topic when it comes to the application of AI. The reason for that is, see, when we are looking at the battery as such or the electric vehicles, the battery is the most important part. It's the most costly part too. That's given. The second thing is also that the warranty stakes are also high when it comes to battery, right? And also the life cycle management of the battery across the number of years that we use. So people previously, how they have used intelligence in the battery management system, for example, is let's say, for example, we want to take a particular trip from A to B. Okay. They would want to understand how the battery is draining, for example, right? And whether the power in the battery that is there as of that particular point in time is sufficient for completing my trip, right? So people used to have these predictions happening at a battery level to say that this much is the remaining battery, and given your conditions, this might actually be the battery consumption that will happen. Now, if you look at the calculations that are related to how do we even calculate these things, actually simple physics, okay, with certain formal equations that lie in the textbook, you can actually come and then say that this is the state of the battery that you have. But the problem is, now what you are traversing along with your electric vehicle also has so many uncertain conditions around it. The traffic conditions that you are navigating through is uncertain. It's unpredictable. The weather conditions that you are going in is not very predictable, right? So all these uncertainties that are there was actually making the simple physics calculations go bad in real time. But that is where AI has pitched in. AI, the nature of AI being probabilistic, it can actually account for these uncertainties, okay, to do the calculations and to give you reliable predictions. So the way that I see this, AI in the battery management system, and also if you look at the battery sizes, right, they are not very big. You cannot host a model in a battery which is an equivalent of a model which you are trying to host it on the cloud. You basically have very much constrained environment within the battery, where in which you have to make sure that your intelligence lies in that battery management system. And connecting back to the point which I said, that it is not just physics that you will use, but you will also use AI, which actually goes to another domain of AI, which is called hybrid AI, where you put your classical physics attached to your AI intelligence and then do better predictions. So and the constraints that you have to work with is you have only limited space within which you can host your AI models. Integrate that with the physics equations that you thought about, you might have written as some expressions in that prediction module, and you bring both of them, and that is where you see the battery management systems getting more benefited with AI, not purely because of AI, but attaching your AI with a kind of a classical model or a physics model, which gives us an understanding of how hybrid AI is much more important in battery management systems than pure AI or pure classical models.
He's referring basically to what we call as physical AI. In physical AI, there's a combination of edge computing because, like you said, you can't really have a lot of data sent to cloud and wait for a response from the cloud, right? So that is where I think a lot of what Caleb was talking about, edge computing really plays a big role in this. Of course, you still need cloud computing. It's not that cloud computing is not relevant because you still need cloud computing to teach the models, but the actual application of those models, the learning those models have will be done on the edge computing in the battery pack, what Caleb was referring to.
Interesting. I think India, in your survey, Shankar, ranked amongst the highest globally in AI optimization and AI readiness. Do you guys think that, do you gentlemen think that India can become a major automotive AI engineering hub? Uh, you know, keeping in mind either edge or cloud? Can we become the mammoths in AI engineering, especially for automotive?
Why not? We have all the ingredients, right, Mukul? Let me start from the very first one, right? We have a very, deep and rich engineering heritage. I mean, at any given point of time, we have more than 1 million in engineers that India churns out, and now our, automotive engineering expertise is, there for decades, right? Point number one. Second, we are India, is known as a software powerhouse. The amount of software talent we have in the country is unbelievable. No other country can boast of the software engineers, the software talent that what India has, right? So that's the second one I would say. And the third, the local market, the domestic market, what we have, it's just amazing, right? A huge domestic market where what we have that really, kind of test the products that anybody manufactures under very, very demanding conditions. So if it works here, it should work pretty much anywhere in the globe, right? And the fourth, it's also, kind of important that we do have, a stable government, and some of the policies, that the government has coming up with quite progressive and quite conducive, for India to be, the known as the global automotive hub, right? So I would say it's for us to really grab it with both hands, the opportunity before the window narrows down. It's for ours to take. That's it.
Interesting. One last question to both of you gentlemen. If we were having this conversation again 10 years from today, when all our hair were white, we were using dyes, black dyes and brown dyes, right? What do you two think would have changed most drastically in the automotive world, especially because of AI?
Okay, maybe I'll start and you can add.
Yeah.
Okay, I'll start, Mukul. I think the first one would be, uh, automotive or a car would be known more for the digital services that it provides rather than as a mechatronics product, right? So it's more on the continuous features and functionalities that is being the car is able to give to the consumer on a regular, maybe daily or even hourly basis to enhance his comfort, to enhance his you know uh, experience of driving, right? So I would say that would be the first one, along with the other aspects I talked about from a safety comfort point of view. And the second, I also see kind of changes that could happen in the entire supplier ecosystem, right? You would have, I would see 10 years from there's going to be a lot of consolidation, focusing more on full stack players. When I say full stack, I'm talking about, companies which not only have deep hardware expertise, but also have solid expertise on AI, data, cybersecurity, right? So the number of players would consolidate on who have the ability to be full stack, right? So that would be the second change I would say, and third, being Bosch and having worked in the manufacturing domain, last 3 decades. Third would be also on the manufacturing. There would be very minimal, touch, very minimal manual intervention that would happen, and there would be a lot of, automated. We call it factory of the future, lights out factory, right? So there would be a lot of lights out factory where things happen, very synchronously, and with very minimal human intervention. So future is a lot about the outcome, the results, and not just on the prediction. And I think being in Bosch for a long time, I would say Bosch is poised on all these three aspects, to lead us into the future.
I love that. Bosch is boss in all three aspects.
Yeah.
Caleb,
Yeah.
your take.
From my side, right, I would actually look at the hard problems that we have today. Okay, and then look at the future, like how these hard problems will be taken up, and then make sure that there is something that is being built around these hard problems. One of the hardest problems that I see as of now is, see, technology is an easier problem to solve. It is given. But the fact remains that now imagine even a player who is a newbie, okay, in this whole game, they can also actually replicate what a tier ones can do by using AI, let's say to the extent of 70 to 80%, right? And they can do by all means, let's say by cutting corners, okay. One reason is because they don't have enough engineering depth as we do have, for example. The other reasons could be the commercial reasons. Okay. But today, from the customer side, it's very difficult to differentiate between what is a reliable product and what is not, and how safe that these systems have been built. Correct or not? Now, this I see as a big gap in the market, because you sell maybe a product which is of substandard nature, but the customer is not able to differentiate. Okay. And just because it's a lesser cost, they go with it. Right. So I would see this gap maybe to a certain extent will widen in the coming days. But 10 years from now, people will now start looking at standardizing certain things. Okay. Saying that which is a good product, which is not good product. And the standards would be built around the intelligence part that we have talked about all this an hour's time that we were talking about, right? The certifications gap will also start reducing. So I see that this new AI world in the automotive domain, whatever we are seeing, will start consolidating as we go forward, be it standards or be it the certification processes that are there, that actually can help customers differentiate, okay, which is good, which is bad. And it is also lying on the players like us to make sure that we bring the right engineering depth that we had built as a legacy over the past 100 years, to make sure that AI is being deployed responsibly, right? So that people won't unnecessarily get into problems with respect to the safety aspects, because that is of utmost importance. That's how I see the path going forward when it's come to the world of intelligence in automotive or industry.
Perfect, perfect. Thank you, Shankar. Thank you, Caleb, for this wonderful, wonderful 65 minutes of conversation. On the end
Didn't
note,
realize
I
it,
think
Mukul. Didn't realize
on
it.
the
Thank
end
you.
note, on the end note, I think that in 10 years from today, we would be seeing cars that are a replica of our living rooms. And I think AI will have a critical role to play there. On that note, Yudhveer Singh signing off for Autocar Professional, and we will see you all for another episode very soon on the platform on Autocar Professional. Take care and good night.